And this logic that we're using here to solve these quadratic equations using the method of graphing is the same as the logic you would use to solve any equation using the method of graphing. If you have an equation that is equal to 0, well, we'll just pick one. If you have an equation like, I'm going to pick on E, negative z squared plus 4z equals 4. If you want to solve this by graphing, what you're going to do is zero the equation first, and I would prefer to zero the equation by moving all of the terms to the right-hand side, because I don't want to deal with negative quadratic terms. It doesn't change the answers. What I'm saying is, if you get in the habit of zeroing your quadratic equation so that the quadratic term means the term that has a squared in it, so that the quadratic term is positive, your life will be easier starting today. So I've added z squared to both sides, and I've subtracted 4z from both sides, so I'm left with that. What I'm doing is I'm imagining that it's not that equation, but instead it's this function. And then I'm saying I can use technology to find the x-intercepts of the function. Of course, the x-intercepts are found by looking on the graph wherever y is 0. So if you think about it, if y is 0 gives you the x-intercepts, then you're solving this equation because the equation is 0 equals. Now, we do have a little bit of a problem here because there's no x's, right? But you understand that I'm going to treat the z's as x's, I hope. So in order for you to find the solutions, it's just a matter of you graphing. And it's interesting because in Math 30 this morning, this was an equation that we were solving. It was a trigonometric equation that we had to find the solutions to. And we were solving it graphically, the same way we're solving these quadratic ones in this class. So x squared minus 4x plus 4. Again, you want to try zoom standard. You also want to double check to make sure you've entered it, and I never did look at what I was entering, so I better do that. Yeah, look at that. So x squared minus 4x plus 4 goes zoom standard, which is zoom 6. This is a case where I believe there's going to only be one x-intercept. And when you zoom in or use the 0 feature, you're going to discover that that x-intercept is 2. So there's only one solution, which is x equals 2. Could you do me a favor, please, and take a look over your work and see if you have any questions you would like me to go over. Go ahead.
Number
7? So we have two consecutive even integers. So I'm going to start listing some integers. Integers extend to positive and negative infinity, so I can't write them all, but what I can do to abbreviate them is to say that the integers are numbers like -2, -1, 0, 1, 2, etc. And you know what? I'm going to put an extra one in there to make my point. I mean, I don't think you even need to write this down. You just need to observe what I'm doing here. -3, -2, -1, 0, 1, 2, 3. I could go to 4 as well, but I'm not going to. What I'm going to do is highlight for you the even and the odd integers. The even integers are -2, 0, 2. Even 0 is even. 0 is not some kind of mystical number that's neither odd nor even. It's an even number. And when I take a look at the odd integers are like -3, -1, 1, 3, and this continues on and on and on. When you look at integers, if I said two consecutive integers, then we could always call one of the integers x and the other is x plus 1, because consecutive integers are always 1 apart. But the odd integers are always 2 apart. And the even integers are always 2 apart. So whatever the first even integer is, I'll call x the smaller even integer. The next even integer has to be x plus 2. Let's say the smallest integer is 4. Well, what's the next even one? 6. Well, 4 plus 2 gives you 6. Let's say the smallest even integer is -8. What's the next one? -6. Oh, that's 2 more. So this is going to be the larger even integer. Now, what are we told about them? We're told they have a product of 168. Okay, that means that the smaller times the bigger or the smaller times the next, or the product of x and x plus 2 is 168. If I that's maybe the wrong word. If I distribute that x by multiplying by x and 2, I get x squared plus 2x. I right away at some point, everybody see that I'm getting a quadratic equation because I see x squared. And in preparation for that, I know that I have to zero the equation. So why don't I just move the 168 over now? And now it's primed to be investigated or solved by looking at the x-intercepts of this corresponding function. Let's finish this one to completion. Part of me wants to say, now you solve it on your calculator, but there's more to it than that. So I'm going to enter x squared plus 2x minus 168. I'm going to try Zoom standard first. I'm not really optimistic that that's going to do it. I better check to make sure I've entered it correctly, first of all. I did. I don't see anything. No, but I can use my knowledge of quadratic functions in that I know since this is positive x squared, this is a parabola that opens up. I know that the y-intercept is negative 168. So it goes through the y-axis down at negative 168. Maybe that's where I should start exploring things. Maybe I should just go to my window, and instead of going from negative 10 to 10 vertically, I'm going to go from negative 200. It's just the number, right? You can always change it. Okay, now I can see it, and I'm interested in the x-intercepts. And I don't know if you remember yesterday, but yesterday we did a problem where there were 2 solutions. It was very similar. And I said, but they were actually 2 different answers, even though they gave us the same answer in the end. This will illustrate that point. To see those x-intercepts, I'm going to have to look further to the left than 10, negative 10, and further to the right than positive 10, just because 20 is a nice kind of roundish number. I'm going to try that. I'm almost there. Now, the only thing is I've kind of painted myself into a corner, as they say, because I'm going to have to put my cursor to the left and the right of those x-intercepts, but I haven't left myself a lot of air above the x-axis. So since I went down to negative 200, maybe I'll go up to, I want to say 50. It's probably enough for me to be able to squeeze that cursor in there. I think it is. So I'm going to find the one on the left first. And I get negative 14. I'm guessing the other one is 12. So negative. I just don't want to spend class time doing it. I'm pretty sure it's 12. So you get negative 14 and 12. And this illustrates my point completely. The x-intercept is negative 14 and 12. which means that those numbers are solutions. They're the roots to the equation x squared plus 2x minus 168 equals 0. Right? So that the x-intercepts of the function and the solutions to the equation are the same. But that doesn't mean the two numbers are negative 14 and 12. Those aren't even consecutive integers, are they? They're not consecutive integers. What this means is you have two answers. You have answer number 1, where the smaller integer is negative 14, and you have an alternate answer where the smaller integer is 12. I'll get to what I think you're going to say in a second, but let me finish. Okay? If negative 14 is the smaller integer, then the next integer would be negative 12, right? If x is 12 is the smaller integer, then the next integer is 14. Go ahead.
It should be negative 12 because the product is positive 168.
Can you repeat that a little louder, please?
It should be negative 12 because the product is positive 168 in the question.
Yeah. But again, I don't quite get what you're saying, but let me throw this out here. I am not saying this and this are the two numbers. I'm saying these are the two numbers, or these are the two numbers. And if x, so we have two answers. If x is negative 14, which is an answer, then we add 2 to negative 14 to get the other number in that answer, and we get these two numbers. Are these two numbers consecutive integers? Yes. Do they multiply to give 168? Yes. Okay. Now there's one other thing I have to look at before I go on. So am I clearing up what you were wondering about? Okay. Now, on the other hand, the other x-intercept, which means the other solution, is 12. If x is 12, we add 2 to 12 and get 14. Now, I believe I misspoke over here because I said, are these consecutive integers? And what I meant to say, I believe, was, are these consecutive even integers? And they are. Are these consecutive even integers, the 12 and the 14? Yes. Do they multiply to give 168? Yes. So, as it stands right now, there are two answers, unless the question said two positive even consecutive integers. And I don't think I saw that. It just says two consecutive even integers. What this means is, and I have a feeling in the back they'll just have 12 and 14 as the answer. They do not have that. Do they? Anybody want to check for me? Because there are two answers to this question. There are. Unlike the one we did yesterday where you got the two numbers and the two numbers were the answer, here you get two different sets of answers. But Althea, you're okay with that now?
So are there like two answers for every question?
No, not necessarily. Not necessarily. Sometimes there are. Let's say that what you were finding here had nothing to do with integers, but what you were finding was a time. Okay, I'd have to construct the question, but the question is, determine how many seconds for this to happen. And in your work, you come up with this equation where x is time. And you say, well, I have to solve for time because it says, what's the time? So I'm going to graph it, and I'm going to look at the x-intercepts. And I get these two x-intercepts, right? I get this x-intercept and this x-intercept. And we would normally say then that this equation has two solutions. It has x equals 14 or x equals 12. I think this is a great conversation. I think I've mentioned this to you before, but in math, the word or doesn't mean one or the other. It means one or the other or both. That's what it really means. If you say to me, did you have coffee or cereal this morning? And I say yes. You don't know whether I just had coffee or cereal or I had both. I did have coffee or cereal. Yeah, that's true. I did. But I could have had both, or I could have had one and not the other. So, what this means is the two answers to the equation in my hypothetical time question are negative 14 and 12, except that time can't be negative. So in that case, we don't include that as an answer and we're done. There's one answer. In the case of yesterday, and I think this is valuable to talk about. In the case of yesterday, we were looking for two numbers, okay? And it turned out that the two X-intercepts were something like, don't quote me on this, the two X-intercepts were 4 and 12. And we got that because one of the numbers had to be x, and the other number had to be x plus 8. I know that wasn't the question, okay? But let's say that was the case. What this means, this was the tricky part yesterday, is that there's two solutions. Actually, I'm going to change this. I'm going to change this to the other number being 16 minus x. Okay? So, if this is an answer, then the first number is 14 and the second number is 12. If 12 is the answer, then the first number is 12 and the second number is 4. But it turns out the two different answers happen to be the same answer, so we don't worry about two answers. In the question that was just asked about, the two answers lead to two different answers. They actually do lead to two answers and not the same thing. So, is it always going to have two answers? It depends on the situation, is the best I can say. But I'm glad that question was asked about. Other questions? All right, then we are moving on. And the algebra that is involved in this lesson today should be really easy for everybody, but I know it isn't. Pardon me? I'm sorry, Reese. Does anybody else need the booklet? The algebra that we're doing today should have basically been mastered in grade 9. And certainly when you review the algebra in grade 10, and I will get to what that algebra is, it should absolutely be mastered. But I know for a fact, because I've taught this course many times, that the algebra we're using today is a weak spot for some of you. Okay? You have to get over it somehow. You have to be able to do the algebra we're going to be doing today within 10 seconds. And if it's something that you're stuck on, you need to fix this problem today or very shortly, because you're going to run out of time because the algebra is going to get more and more complicated. I'm not saying this to scare you. I'm saying this to tell you that if you're struggling today, it's not going to get better unless you fix it. And everything's fixable. One of the problems, I sound like an old man, is you're too reliant on your calculator. So when we start talking about multiplying numbers together, I see this all the time. Okay, so we have 2x times 4x, and people start going 2 times 4. Really? 2 times 4? You don't know 2 times 4 is 8? we need to use these number facts, okay? So we're going to be spending the next 3 days at least on this section, 20.4.2, and it deals with basically factoring. And I consider this to be part one, the basics. There is a relationship between the x-intercepts of a quadratic function and the zeros of the equation, and there is also a relationship between the zeros of an equation and the factored form of the quadratic expression. And that's what we are learning today. We're going to be solving quadratic equations that look like this, x squared plus bx plus c equals 0, using different methods of factoring. I want to point out to you that in this equation, x squared plus bx plus c, it's 1x squared. So in every equation we look at today, we boil it down to 1x squared plus some number times x plus c equals 0. If the number is not 1, like it's 3 or 4 or 5 or 7 or negative 12, then we got problems, and we'll deal with those problems tomorrow. So as a warm-up, part A, it says factor this polynomial. It's a quadratic polynomial. Notice, by the way, there's no equation here. There's no function. It's just a polynomial expression. And I will remind you that when you factor a polynomial that looks like 1x squared plus bx plus c, if it's factorable, and they're not always factorable, they will factor into two binomials. A binomial is a polynomial with two terms. This polynomial is quadratic, and it's a trinomial. It's quadratic because it contains the variable squared, x squared. It's a trinomial because there are three terms. These are both linear binomials. The language and the terminology is just as important here as getting the answer. I put a lot of thought into how I design these lessons and what I decide to say, and I'm saying this is important because then when you get to 30, when I start talking about a cubic binomial or a cubic trinomial or a quartic, you're familiar with the language, even though you don't know what cubic and quartic means. So when you factor a binomial, or sorry, a trinomial that looks like this, I'm going to use a little bit of symbolic language here. It will factor into x with a number and x with a number. And those two numbers have to multiply, bless you, to get c. And those two numbers, and you know what, I'm going to rewrite this, and just to make sure you know what I mean, I'm going to put a multiplication dot in between there. Whatever those two numbers are, they have to multiply to give c. But they also have to add to give b. This is the basis for what we're doing today. And you learn how to do this in grade 9. You do it again in grade 10. And the assumption would be, for an inexperienced teacher, the assumption would be everybody knows how to do this. I mean, the question becomes, what two numbers multiply to give negative 10 and add to give negative 3? I know the answer almost, I get the answer almost in the time it takes me to say the question. So we want two numbers that multiply. Now let's get to what we're trying to do here. We have x squared minus 3x minus 10. We want to find two numbers that multiply to give negative 10. I'm going to use the symbols again. I like the symbols. We have to find two numbers that multiply to give negative 10. Those same two numbers have to add to give negative 3. So how many of you have the numbers? See, that's a little concerning to me. Fewer people have the numbers than don't. So how do you do this? You start off by saying what two numbers multiply to give 10. I'm not worried about negative 10. I'm just saying 10. And if your immediate reaction is to go to your calculator to find out what 10 is divisible by, I don't know how to help you. I really don't. I'm not trying to be a jerk today. I'm just saying if you don't know what numbers divide into 10, what numbers are factors of 10 without using your calculator, then you're in trouble. So 10 is either, this is kind of the thought process going on in my head. 10 is either 1 times 10 or 2 times 5. That's it. I mean, in terms of integers, that's it. In terms of whole numbers, that's it. So then I say to myself, but they have to multiply to give negative 10. So one of these is positive and one is negative. Now, they have to add, when I make one of them positive and one of them negative, they have to add to give negative 3. Which means I'm looking, this is kind of a tip, I'm looking for a pair of numbers that are 3 apart from each other. Because one's going to be negative and one's going to be positive. So it must be the 2 and the 5. They're 3 apart. There are 2 and 5, 2 and 5. But they have to multiply to give negative, so one's negative. They have to add to give negative 3. Well, I guess the 5 is the negative one then. Because if they're adding to give a negative, the larger of the two numbers is going to be negative. In other words, everybody, this factors into x plus 2, x minus 5. Good? That took me maybe 5 minutes to explain. Again, and I realize that you're out of practice with factoring, but the factoring is going to get worse, and you should be able to look at that and go, let's see. Oh, yeah, x minus 5, x plus 2. Okay, we're not going to be giving you really complicated ones usually. Let's move on to warm up 2. Solve this quadratic equation. Now, I want you to recognize that this quadratic equation of x squared minus 3x minus 10 equals 0 contains the quadratic expression that we just factored. Okay, there's a connection here. So I want everybody to solve that on your graphing calculator. So what you are doing to solve this is you're looking at the x-intercepts of the function y equals x squared minus 3x minus 10. I'll just give you a minute to finish doing your analysis on your calculator. Just to show this to you, you would graph y equals x squared minus 3x minus 10. You would go zoom standard. You would then use your tools on your calculator to determine that that parabola crosses the x-axis at -2 and it crosses the x-axis at +5, which means the solutions to this equation are -2 and +5. Now, there's lots of ways you can answer the rest of this question. What do you notice and why is this the case? This is where I really want you to grasp the understanding of what's going on here. Some of you will probably say that the answers here, the solutions to this equation, are the numbers that are in the factored form, but they're opposite, aren't they? That's kind of a tortured way of using the English language to describe what's going on. So let's be a little more precise. We have to introduce something. You already know about this terminology, but it's going to seem a little different. I'm going to call this factor A and this factor B. The zero of A is the number for x. Listen very carefully. The zero of this factor is the number you would put in for x to make that factor 0. What number would you put in for x so that the number you put in plus 2 gives you 0? Negative 2. The zero of this factor is negative 2. The zero of factor b is the number you would put in for x to make the second factor 0. Well, if you have x minus 5, if x is 5, then you'll get 0. So that means that 5 is the 0 of that expression. So what we notice, and just hold off on writing too much right now, is that the solutions to this equation, which can be thought of as zeros, the zeros of this equation. Maybe we'll try something. Do me a favor, take your calculator. Put negative 2 in for x. So you're going to put negative 2 in brackets squared, minus 3 times in brackets negative 2, minus 10. I hope you know you're going to get 0, right? Because it's an x-intercept, which makes y 0. So the zeros of this equation are the zeros of the factors that make up the equation. Think about this for a second. This x squared minus 3x minus 10 is the same as x plus 2, x minus 5. Is there any difference between version 1 and version 2 of what I've written? No. Mathematically, they are exactly the same thing. So why should a 0 of x plus 2 make this equation true? The answer is very simple. If this is 0 and it's being multiplied by something else, I don't care what it's being multiplied by. If it's 0, you're going to get 0. So what we learn is the following. This is the bottom line. The roots of x squared minus 3x minus 10 equals 0 are the zeros of the factors x plus 2, x minus 5. Wow, I better write it properly. Are the zeros of the factors x plus 2 and x minus 5. Whatever value of x makes each factor equal to 0 will make the whole thing equal to 0, because a factor is going to be multiplied by other factors to get the whole thing. For example, now we're going to keep the equal 0 here when we work on this. We're not going to factor this thing without the equal 0. Is this factorable? Well, I'm going to give everybody a minute here. We are looking, and I'm just going to write my scrap work over here and then erase it. We are looking for two things that multiply to give negative 27, but those two things have to add to give 6. I'll give you a short minute to find those numbers. And you start off with the multiplication thing. You start off by saying, what are some numbers that multiply to give the 27? This is an easy one if you know your times table, because 27 is either 1 and 27 or 3 and 9. I don't think there's any other factors. And 3 and 9 are 6 apart. So that's good. If I had 3 and 9, but the 9 was positive and the 3 was negative, that would give me positive 6. And then negative 3 times 9 is negative 27. So this factors into x minus 3, x plus 9. Now, I know that most of you should know what the answers to the question are. But, and I want you doing this, I want you writing the following. You have to get into this habit. If x minus 3 times x plus 9 equals 0, then x minus 3 equals 0, or x plus 9 equals 0. Right? This is the reasoning. If the two things multiplied together have to give you 0, then if one of them is 0, the product will be 0. If the other is 0, the product will be 0. And the reason why I want you doing this, I hope everybody can look at this and say, oh, it's 3 and negative 9. I want you to understand that you're solving now linear equations. You have gone from a quadratic equation, which prior to today you could only solve on your graphing calculator, to 2 linear equations that a grade 3 student could solve. Well, you might have to have a conversation with them about negative numbers and stuff like that. But you get my point. Some number minus 3 equals 0. Well, the number's 3. You add 3 to both sides. And you don't have to do this. Some of you might need to see this to understand the answer is 3. We could subtract 9 from both sides. Again, I don't think most people have to do this, but some of you might need to see it. So the two solutions are 3 and negative 9. And the things that I want to see in your work are this, and that includes the equals 0, this, and your answers. There's a reason for this. I'm not trying to be difficult, but when we get into, I can take Math 30 just this morning, and tomorrow we'll be doing more stuff. Minus 1. We'll encounter equations like this. Now, I realize that this is called 2 secant of x. You don't even know what that means. But the bottom line is, in order for you to understand what to do mathematically in Math 30, you have to be able to do this. You have to say that factor can equal 0. I'm going to rearrange that for the unknown. Now, you don't know how to rearrange this for the unknown. I always like throwing something like this out at you. You know there's sine of x, cos of x, tan of x. There's 3 more. There's secant, cosecant, and cotangent. There's 6 trigonometric ratios, and that's one of them. So the more you get used to this pattern of doing the highlighted stuff, the more comfortable you'll be with more complicated things. Okay, don't skip any steps here. All right, I'm going to stop writing my squares and triangles and goofy shapes here. This is going to factor into k. I need 2 numbers that multiply to give 50 and add to give negative 15. So let's think. They multiply to give a positive. That means the 2 numbers are either both positive or both negative. Can't be plus and minus. It's got to be plus and plus or minus and minus. And the reason it has to be minus and minus is they have to add to give negative 15. So now I just forget about the negatives. What are the numbers that multiply to give 50 but add to give 15? Well, 50 is 2 times 25. Well, 2 plus 25 isn't 15. 5 times 10. 5 times 10 is 50. Oh, 5 plus 10 is 15. So that means that k minus 5 equals 0. It also means k minus 10 equals 0, which means k equals 5 and k equals 10. Which, by the way, this is interesting. If I said to you algebraically, don't change anything. If I said to you, come on, find the x-intercepts of that function, or the k-intercepts, but you can't use your graphing calculator. You do this. These are the x-intercepts. X squared minus 16x equals 80. Well, you first have to zero this equation, which means we subtract 80 from both sides. This is going to be a case where one of these will be a positive number and one of these will be a negative. Now, I don't expect you to know all of the factors of 80. You can use your calculator, of course, but you have to find two numbers that multiply to give the negative 80 and add to give negative 16. When you find them, and it's not a rush, when you find them, put your hand up and then down again. Okay. And keep that going. Once you find them, put your hand up and down. Good. 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 So I think you've kind of picked up on the fact that I don't worry too much about the negatives. I put them in when I need to. So what I do is I start off with the number 80 and I go, well, it's 8 times 10. I know that. It's 8 times 10. Okay. Now, unfortunately, 8 and 10 cannot be combined to give negative 16, even if one is negative. So what I can do is I can take half of this and double this, and it should still multiply to give 80. Or I could take double the 8 and half of the 10, and that should multiply to give 80. And I think I've kind of, in that little process, kind of found all of the factors. And I noticed that the 4 and the 20 differ by 16. So 4 times negative 20 would give me the negative 80, and 4 plus negative 20 would give me the negative 16. And I have to ask a favor from many of you. I know that many of you are bored at this point. You get this. You could do it. But I'm not here just for some of you. I'm here for most of you or all of you, hopefully. I'm going to just cut to the chase here and say that. So I'm skipping a line that I would want to see in your work, particularly if it were written response. But let's face it, going from here to here is not, it's a fool. He doesn't even look at me. It's very easy, isn't it? It's very easy. Okay, so, boy, you don't want to try to factor something that has a negative x squared or a negative p squared. You want positive quadratic terms. So when we zero this equation, I'll tell you what, even if it were this, negative p squared plus 27p minus 6p equals 0, even if it were zeroed, you don't want it zeroed like that. You want a positive quadratic term. This is the quadratic term. This is the linear term. This is the, oh, this is a linear term as well, isn't it? Do you have 6p or just 6? No p on the 27? Okay, thank you, Seamus. Yeah, I didn't want to introduce you to that yet. So, this is actually the linear term here, and this is the, it's called a constant term. But anyway, I got a little off track. It's a good thing that I found that typing mistake. So it's written correctly now? Okay. So even if I wrote it to you the way it is in this second line, negative p squared, maybe I put minus 6p plus 27, you don't want to work with that. Move everything to the side that makes the p squared positive. So you don't want to do this. What you want to do is p squared plus 6p minus 27. I'm not doing anything fancy here. We call it transposing terms. When you have a term on one side of the equals and you move it to the other side, you just switch signs. Now, look up here, please. I moved everything to the right side, correct? So that means this, right? I will almost never write that. Even though I moved stuff to the right, it's still equal to 0, right? If you want to put the 0 on the left, you can, but it doesn't matter where you put it. So have at her. Looking for two numbers that multiply to give negative 27 and add to give 6. It's easy. We had one very close to that. It's going to be the 9 and the 3 combination. Plus 9 minus 3. So p equals negative 9. And p equals 3. Really not difficult. Questions with that one? Okay. So 7x squared equals negative 49 plus 56x. I'm going to zero the equation and write 7x squared minus 56x plus 49 equals 0. So what's the deal here? Because I said what we're doing today has a coefficient on the x squared of 1. And now I've got a coefficient of 7. But we have to make it 1. How? Well, I guess we could just erase the 7, right? But that doesn't work. You can't just change the question. Any ideas here? Brody? Yes, factor out the 7. Now, how many of you were thinking possibly divide both sides of the equation by 7? Let's not do that. There's nothing wrong with that. I want you to get in the habit of factoring it out and leaving it there. I know since it's equal to 0, Thomas, you could divide both sides by 7 and it would just go away. That could cause problems later. So we're going to go with what Brody said here. We're going to factor the 7 out. So you will notice that 7 is a factor of 7, of negative 56, and of 49. It divides nicely. So we get x squared minus, well, what number times 7 gives you 56? That would be 8. And then plus 7. Because 7 times 7 is 49. Thomas, we could easily get rid of the 7. And if I were working on my own, I would. But it could cause confusion with other students later on. So just leave it. It doesn't do any harm. And carry that 7 all the way through this quadratic factor. So we have 7 as a factor. And then we have the quadratic factor. The quadratic factor is now in a position to be factored because it's 1x squared. What are some numbers that multiply to give 7? 7 and 1, right? Or negative 7 and negative 1. But the numbers themselves, without regard to positives or negatives, are 7 and 1. Since I have to add them to get negative 8, they have to both be negative. And now I say x equals 1. and x equals 7. So this factor leads to this solution. This factor leads to this solution. And invariably somebody says, well, what does this other factor that I've highlighted in yellow lead to? And the answer is nothing, because there's no x in it. Doesn't matter. It has nothing to do with x. What number for x makes the green factor 0? 7. What number for x makes the blue factor 0? 1. What number for x makes the yellow factor 0? Well, that's a crazy question, because there's no x there. Right? I think you know where this last one's going. You can use your calculator, of course, to factor that 8 out. It's going to be t squared minus 9t plus 14. Again, I'm not saying you have to be able to do it in your head. When you're getting to like 112, you probably want to even take your calculator and see if 112 divides by 8 to begin with. Right? But it is 14. That means we are now looking for two numbers that multiply to give 14 and add to give negative 9. Well, they're both going to be negative again. 7 and 2. So negative 7, negative 2. That means t minus 7 is 0, and that tells us that t equals 7. T minus 2 is 0. That tells us that t equals 2. You need to be able to just burn through these types of questions. Because math is ultimately used at some point to solve problems in the real world. And the real world isn't going to be so kind as to have a 1 in front of the quadratic term all of the time. So this is just the first layer of what we're doing. What if you can look ahead at the next lesson and see the things we're going to factor. You need to know how to factor more and more complicated things as days go on. So on page 4 of the unit handout, if you take a look at page 4, I believe there are 40 quadratic equations. I think, correct me if I'm wrong, 1 to 20 have a coefficient of 1 in front of x squared, and then at 21 it switches. So all of the ones from 21 to 40, you have to factor that out. Okay. And I would say at a bare minimum, you do every odd question. Okay. And many of you will just burn through this like in 15 minutes, you'll be done. Others, it will take longer, but this is where I get a chance to walk around the room and find out at what levels you're at in terms of factoring. So everybody please get settled in and get started. I need to take attendance, and then I will come around and help you out.